Hi everyone. In this video, I want to demonstrate how to conduct unit 2 test in R. So we'll be conducting the augmented equivalent unit 2 test and Philippe Perron unit 2 test. So I'll be demonstrating both of the tests in R. So here I want to assume that you've set your working directory. So that's my assumption. I want to assume you've set your working directory. I'm starting from data importation. So I've already imported my data. So the code to import your data is just this. But let me import the data set. So I import the data set. Then I want to transform some of the variables in my data set. So I want to transform nominal GDP to log of nominal GDP, and I want to transform money supply into log of money supply. So now I'll be using LNGDP to um, to represent log of nominal GDP, and I want the LMS to represent the log of money supply. So let me load the necessary package so that I'll be able to transform the variables. So like I said, you can use either tidyverse package or deplet package. So I've chosen to use tidyverse package. Let me load the package. So let me load the package. That is line 3. I load the package has been loaded. You can see no error is reported in your console. So it means the code has been run successfully. So now let me transform the variables. The two variables I want to transform. I have nominal GDP and money supply. So I run the code on line 4. You can see if I run the code on line 4. So that will help me to transform my variable. So these two variables have been transformed successfully. So I can actually view it. I want to view it to see that I have additional variables. Okay. You can view it. If I want to view, I just use TSD. TSD, I can even place my cursor here, or I run it. It's coming. You can see I have more variables here. Okay, more variables here. You can see I have more variables here. So I have log of nominal GDP and log of money supply. So it has been generated for me. It has been generated for me. So you can see now to conduct unit root test, there are like packages you can use. You can use C series, the package called T series, or you have CA. Okay, you have CA. So this URCA library, so is the best they use because it allows you to select lag using information criteria such as AIC and BIC. Okay, so now let me run the library, the package for unit root test. If I run the package for unit root test, that is the code in line 8. You can see I've loaded the library. Okay, so with that, I'll be able to carry out my unit root test. Now, I want to use this. This is just like anything, I can write anything. So it's just to assign my results. So I want to ask, this is the main function. This is the function to carry out augmented equivalent test. And the function is URDF. Okay, so you can come here to see details on this function. Because I've already installed this package, which is URCA. So let me look for the URCA package. I'll search for that. You can see if I click here, it will give me details concerning this particular line. You can see this package. Okay. So let me go down where I have you have. You can see you have DF. You can see this you have DF. Say augmented equivalent unit root test. If I click on this URDF, it will give me information about that. So you can see, so it performs augmented equivalent unit root test. You can see the structure. So this is a guide on how to use this particular function. Next function you have .df. Okay. and this is the guide of this. Okay, so now going back to our work here, so I just use anything here just because I want to use it to store my result. This is what I want to use to store my result. That is why I write it on the right hand side and I assign the results here to it. So meaning that, so whatever the results that is got here should be stored in this name. It should be stored with this name. So if I run it now, you can see you have .df, that is the function to perform augmented behavioral test. So in function always has brackets after it has been seen, and here are the argument, here is the function I have to fill in that function. So I have TSD, I put $LNGDP. Dollar here, this dollar is telling how that it should look for, it should check TSD dataset. And is it this TSD dataset, it should pick LNGDP. Okay, and here you should use none. That is this one, by telling how to use none, it means that we want to perform augmented behavioral test with no intercept and no trend. No intercept and no trend. That is none. So you must have done something like this. You have seen something like this using when you use eViews and some other packages. And we want, because I want how to select lag, the optimal lag for me using AIC criteria. AIC criteria, that is why I say select lags equals to AIC. So I want to run it now. Let me run the code. If I run the code, yes, the code has been run. Now, let me see the result. I write summary and I put the name I used to store the result inside this function summary. So to see, once I click OK, so the result will come. So the result I need, that is the last portion here. So I only need the result of the last portion here. You can see here, I have the result of the test. You can see, say 3.0241. Okay, because you now compare with the critical value. So you can see the critical value here. But don't be confused. You might want to say, yes, this is significant because this critical value is greater than this. No, because the assumption, so most people think that once the critical value is greater, no, it's not that it's greater. Yeah, when as far as the unit two test is concerned, because the t statistic for augmented the behavioral test must be negative. Okay, it must be negative. Your result must be negative. Okay, so it must be more negative than the critical value. That is what we are saying. So mean that it must be more negative than the critical value, not that it must be greater than the critical value. That is wrong. It must be more negative than the critical value. You can see this is not negative. This is sign of explosion. That's this variable is not stationary at all. This variable is exploded. That's what it means. Adding in it, we have minus 3.025. We'll have said, okay, this is greater than, this is more negative than the minus 1.95. We are using 5%, which is the conventional level of significance. So we say it is stationary, but this one is positive, so it's out of the game. So it means that this is not stationary. That is the log of nominal U is not stationary at level if we don't improve constant and trend in our specification. So let's check for the for another specification that we want to include intercept. Okay, we want to include intercept. Now, so the first one we say we don't want intercept and trend. Now we want to include intercept, but we don't want to include trend. So here we have similar code. The only difference is dot drift. Drift here means intercept. So if I run the code here, okay, so it has no. So let me see the result by running the summary function. If I run it, you can see you can see the T statistics value. You can see here we have, this is the value, not the one you have here. This is what we are after. Okay, you can see this is the T we are after, which is tau. Okay, is tau. This other one, this weapon, this is this T statistic for T here. Okay, so this is for phi here. Okay, so we are not interested, we are only interested in the first t value here. So if you look at it, so if we use and continue using conventional 5% level significant, okay? So if you look at here, so this is less negative than this. So it means that it's than minus 2.28. Although it's negative, but this is less negative than, that is the negativity of this test value is less than that of this one. Okay, that of what? That of this one. Okay, now, so again, our variable is not stationary. So let's look for the third specification, which is the last specification, that we want to include both the trend and the intercept. Both the trend and the intercept. Look at it. So the type, we are going to change the type to trend. So if I run it, okay, if I run it now, so now let me see the result by using summary. Let me see. Okay, you can also see that yes, it is also next negative down. You can see the result of the tau. That is where what you are after. Here you can see. So this is less negative than this. Okay, so again, using all these three specifications, so GDP is not stationary at level. Now, again, let's check for GDP at first difference, whether it's stationary at first difference, the difference our log of GDP. So now let me start. So that one is starting from line 23. Now, so the only thing I'm going to add this, then I put a bracket. That is, I'm telling how to first difference this variable before applying this function. So if I run this, then let me see the results. I can see if I see the result here, you can see good. This is more negative than this. You can see so it is stationary. Okay, that is this GDP is stationary at first difference. Okay, it's stationary at first difference. It's stationary at first difference. So we might want to check for other specification. Let's in this first one, if I'm not including uh uh intercept and trend. But here, now let's include intercept. If we include intercept, let's see how the result will be. So that is the code, what the code we have in line 26. If I run this code, yes, the code has been run. Now let me run the result. You can see again, this is more negative than this. Even this is not even better than the one with no constant and trend, because this one has actually moved up. You can see that minus 4.4268 is more negative than minus 2.93. Okay, so again, it's the same at first difference. Let's look for the last specification, which is for no log of GDP when we include the trend. Let's see how it's going to be. Let me run that too. If I run that, okay, now let's see the result. We look at the result. If I look at the result, you can see again, it is stationary because it's more negative than this. So that is about a unit root test, that's augmented irregular test, unit root test on log of GDP. So the same thing applies to other variables. So you can, I will want you to do that on your own. You can do that. You have the data set. You can do it. Just the same structure is only the name of the variable that that has been changed. Now let's move to the other test, which is Philip-Perron. So it's also a unit root test. So some researchers, okay, let me say most researchers actually use both tests, okay, for robust. They check whether the result will contradict or not, okay. But in most cases, we we don't have a contradicting result, okay. But we have exceptional cases anyway. So now unit root test, Philip-Perron unit root test. So you can also check the details about Philip-Perron unit root test in UCAR library. You can see this is a UCAR library, so just search for UCAR here. That is, you have CA. Now Philip-Perron PP. You can search for that PP. Philip-Perron. So you have the PP. So let me just search for you have. You see, or you can just code and it does not come. You can see you have this is the function. Function you have dot pp. Let's fill perimeter. If I click on it, it will bring out the details about this. So yes, it has brought it. You can see you have pp. Fill parent perform unit. So here is the function, the structure. Okay. So we always you go for short. You also go for long, but we rather go for short. Okay. So now we use tau, this tau. And the honest we have just two specifications here, that is constant and trend. Unlike augmented reverted, when we have selection for no constant and trend, and we also have for intercept only, that is constant only, and we also have for trend and constant, that is intercept and trend. So constant and intercept are the same thing. Okay, so you can see. So that is what we have. You can see the same structure you have. So you can always go to the package and see a guide on how to perform, how to use any function, okay, in that package. So here you can see we have ur.pp, okay, so have the same structure. So the type we have the zip tau. So I want this to show me the sort of tau and the model. So instead of same type, so we say model constant. So we use constant. That is the one we train because we don't have the one with no constant and trend. And lags we use short. So if I run it, you can see that's been run. Now let me see the result using summary. I can see the result now. You can see the result. So I have the same result that this. Okay, I'm going to compare with zero. It's less negative than the 5%. You could have like 5% level of significance. You can see it's less negative, so it's not stationary at level. So the same conclusion we reach when we apply our augmented regular test. Now, for trend, if you include trend, let's see if we are going to achieve stationarity. So if I run this for, intercept and trend, that's line 79. If I run it now, let's see the result summary. Let's run summary function. You can see it's still net negative. So it's not meaning that log of GDP is not stationary at level. So we reach the same conclusion as what augmented regular test showed us the other time. So let's apply this on first difference of log of nominal GDP. Okay, so the only thing that changes is just diff. We put diff. That is the function for difference variable. So now let me apply this. If I run this, yes, that's been run. Now let's see the summary of the result. You can see this is more negative than this critical value. It means that it's stationary at first difference. Log of GB is stationary at first difference. So the same conclusion we reach when we applied augmented equivalent test. Now also, if we include trade, let's see how it's going to behave. Yes. Now let's see the summary. Again, it's more negative, okay, than this. We're going to see that it's also stationary. So we reach the same conclusion as what we reach when we apply augmented equivalent test on this. So you use the same approach uh, for uh, for the remaining variables. So you apply the same approach. You have the code here, so you can run the code on your own. So just follow the steps like just shown now. So you are going to get it.